We are now solving question number 4 of differentiation of A2 levels. The question is the parametric equations of the curves are x is equal to 3 minus cos of 2 theta and y is equal to 2 theta plus sine 2 theta, where theta lies between 0 and pi by 2. Show that dy by dx is equal to cot theta. Since these two equations are parametric equations, parametric means that two variables x and y they depend upon the variable theta there. So that is why they are known as to be called parametric equations. So we will find dx over d theta, where x is equal to 3 minus cos of 2 theta, 3 derivative is 0, minus 2 cos 2 sine of 2 theta, because cos derivative is minus sine. So this thing will become equal to 2 sine of 2 theta, and that's it, that is expression number 1. Then for the second expression, y is equal to 2 theta plus sine 2 theta, then dy on d theta is equal to 2 theta derivative is 2 plus sine 2 theta is derivative is 2 cos 2 theta, and that's it, that is 2. Now you will divide equation number 2 by 1. So dy over dx is equal to dy on d theta over dx upon d theta. Whereas dy on d theta is equal to 2 plus 2 cos 2 theta over dx over d theta is equal to 2 sine 2 theta. Now you can take 2 common there. 1 plus cos of 2 theta over 2 sine 2 theta, 2 and 2 cancel, but 1 plus cos of 2 theta is equal to cos square theta minus sin square theta over 2 sin theta cos theta, and that thing is equal to 1 plus 2 cos square theta minus 1 over 2 sin theta cos theta. This 1 and minus 1 cancel out. It is 2 cos square theta over 2 sin theta into cos theta. This and this cancel out. Cos square is cancel out this. So that thing is equal to cos theta over sin theta, and that thing is equal to cot theta, which we have to prove in this part of this question 4 of this. In the bottom, we have given the three identities which will be used in this question. Cos 2 theta is equal to 2 cos square theta minus 1. Sin 2 theta is equal to 2 sin theta cos theta, and cos square theta plus sin square theta is equal to 1. Now we are moving toward the next question. It is given that the diagram shows the curve which has x is equal to tangent theta and y is equal to cos square theta, where theta lies between minus pi by 2 to plus pi by 2. Show that the gradient of this curve at the point with the parameters theta is minus 2 sine theta cos cube theta. This question is in the parametric form where x and y are depending upon theta. So you can calculate dx over d theta. Tangent theta derivative is secant square theta. Let's say that is 1 dy upon d theta, that is equal to 2 cos theta into minus sin theta, because 2 power will become coefficient, and without function power cos theta derivative is what? Minus sin theta. So let's say that is 2. Now dividing 2 by 1, so dy over dx will be equal to minus 2 sin theta into cos theta over dx by d theta is secant square theta. But secant square theta is equal to 1 over cos square theta. So that is going to be multiplied by here cos square theta. This thing will become minus 2 sin theta cos cube theta is the derivative of this, which we have to show. So dy by d theta x is equal to minus 2 sin theta into cos cube theta. Now we will change it by finding the second part. The gradient of this curve has its maximum value at the point P. Find the exact value of the x coordinate of the point P. Since this is the curve which lies between from minus pi by 2 to plus pi by 2, and P is the point on this curve which has its maximum value, and we are going to find out the value of the x coordinate of that point P. So whenever it is maximum or minimum, you will have to find out the second derivative of this. So dp dy over dx is equal to minus 2 sin theta into cos u theta. Because it is the parametric form, so we will change it in the form of this terms of x and y there first. So we can write it this equation as minus 2 sin theta into cos u theta. If we divide it on both sides by cos theta and multiply it by cos theta, then this equation will become minus 2. This portion is basically equal to tangent theta, and sin cos into cos will become cos of 4 theta. And that thing is still equal to dy by dx. Now, this will be equal to minus 2 tangent theta, because y is there cos square theta. So, this equation will become cos square theta whole square. Now, it is still dy by dx. So dy by dx in terms of x and y minus 2. Tangent theta itself equal to x. So it should be equal to x into cos square theta is equal to y. So this thing will be equal to y square. Or we can write this thing as minus 2x over y square. Or even y square is basically equal to minus 2x over minus 2x into y square. That can be written as minus 2x over 1 over y whole square, because y is basically equal to cos square theta. So this thing will become dy over dx is equal to minus 2 of x over 1 over y. 1 over y is 1 over cos square theta, and that thing is equal to secant square theta whole square. This thing is equal to minus 2x over secant square theta is basically equal to 1 plus tangent square theta whole square. So that thing is equal to minus 2x over 1 plus x square and whole square of that. Basically, now you have converted this whole expression in terms of the parametric form of x and y there. And now this thing is going to be converted for the second derivative. D square y over dx square is equal to 1 plus x square whole square, as it is 1 plus x square power 2. Now this will become power 4. 1 plus x square power 2 into minus 2 minus into minus 2 of x into 2 into 1 plus x square into 2 of x. This expression is going to be equivalent to minus 2 into 1 plus x square whole square. This minus and minus will become plus 2x into 2, 4x into 2x, 8x square into 1 plus x square divided by 1 plus x square whole square. Because it is the maximum point, so you put second derivative equal to 0. So this is equal to when 0 there. If you cross multiply, this expression will be equal to 0. So it should be equal to minus 2 into 1 plus x square power 2 plus 8x square into 1 plus x square is equal to 0. This thing, if we open it, minus 2, 1 plus x 4 plus 2x square plus 8x square plus 8x4 equal to 0. If you multiply this, minus 2 minus 2x4 minus 4x square plus 8x square plus 8x4 is equal to 0. This 8x4 and minus 2x square will become 6x4 minus 4x square plus 8x square plus 4x square, and this is minus 2 should be equal to 0. Since it is the quadratic equation in terms of square, so let x square equal to p, then x4 is equal to p square. So this expression will become 6p square plus 4p minus 2 equal to 0. If we divide it by 2 on both sides, this will become 3p square plus 2p minus 1 equal to 0. If we factorize this thing, it is 3p square plus 3p minus p minus 1 equal to 0. If 3p is common, p plus 1 minus 1 is common, p plus 1 equals 0. So p plus 1 into 3p minus 1 equal to 0. So p is equal to minus 1 or 1 over 3. But p value itself equal to x square. So it cannot be equal to minus 1. So this minus 1 value will be rejected there. Then x square is equal to 1 over 3. Then x is equal to plus minus 1 over 3 square root, which is equal to 1 over square root of 3 plus minus there. But the value of p is going to lie on the left side of this equation. So this positive value will be rejected there. So x value is equal to 1 over root 3. And that is the required answer for this question. But since you need in the rationalized form, so x value is equal to 1 over root 3. You multiply it by root 3 and divide it by root 3. So this thing will become root 3 over 3 is another value of x, which is being calculated by this 1 over square root of 3 there. So this is the x coordinate of that point P, which lies on this curve there. And this is the way to solve it for the whole question for the coordinates of P.